Assalamu alaikum, dear students. We are discussing the special functions. Yesterday we discussed the modulus function and the identity function. Today we will continue this very topic and we will define another function, that is the constant function. Now a function f from R to R, that is its domain is R and its codomain is also set R. That is, f is a function from R to R defined by f of x equals to c. Defined by f of x equals to c for all x belongs to domain, means for all x belongs to R, where c is any constant or the real number. So this means that the function which maps each and every rational real number to a particular or to a fixed number, such very function is called as the constant function. Like if we consider a function defined by f of x equals to 5, this means that this is a real function, its domain is set of real numbers, it maps each and every real number, or it relates each and every real number to 5. That is actually, this f is actually of the form of, in terms of ordered pair, it is of the form of x comma 5, that is ordered pair x5 where x is real. So this means that it is such a function whose second entries are same throughout for each and every ordered pair. So clearly its domain is R, because x means set of first entries is the domain, it is the first set, so it is simply R, and its range is simply set C. If we define f of x to be C, or if we define f of x to be 5, so this means that then it is domain, this range is simply set singleton set 5. Now how to draw the graph of this very function? Now in order to draw the graph of this function f of x, we will assume that this c, the function which is defined like f of x equals to c, we assume that this c is positive. C is, because c is real number. Real number may be positive, negative, or 0. So this means that this we will assume here, in order to draw the graph of this f of x equals to c, we will assume that f of x is positive. Now here this c is positive. Here c positive, f of x equals to c means it is the range set. So this means that definitely it is the point on the y-axis. Now when x and y, we will draw this, we will tabulate the range points as well as these domain points. Now when x is 0, y is c, means y is f of x. When x is 1, y is c. When x is -1, y is c. So everywhere it is c, c, c. So this means that, let us say that c is at a distance of these units from the origin. So when x is 0, y is c, so c is point here. When x is 1, it is c. When x is 2, it is c. When x is 3, the point is here. So we will join all such points. So when we will join, we will get a straight line, this very straight line passing through point c. This point c, here point is the c, passing through c and parallel to x axis. So this is the graph of this very constant function. Now if c is negative, then we have to draw the graph here, like in this f of x equals to -5. It is simply the -5 is below the origin, so this means that it is a line passing through this very x, passing through -5 and parallel to x axis. So the graph of this constant function is always a straight line parallel to x axis. Now if f of x is 0, because 0 is this means that it is simply x axis. Because x axis is the only axis which is at a distance of 0 units from the origin. Now if we have here -5, here -5 indicates simply the direction, it is below the origin. So this means that it is at a distance of 5 units from the origin, but below the origin. So in this way you can draw the graph of each and every x, this constant axis. Now the polynomial function, second one is the polynomial function. You know what is polynomial? A polynomial is simply the linear combination of the expressions. or if we consider it to be a function, then it is a real valued function or simply a real function. Real function means domain as well as range is set of the real numbers, or the codomain is set of real numbers. So the function defined from f from a to or defined by f of x equals to a naught means a0 plus a1 x plus so on to a2 x square plus so on to an xn, where an is not equals to 0 is the polynomial function, where n is simply an integer, you know it, which is called as the degree of this polynomial. And these i's a naught a1 so on to an are the constant with the property that an is not equals to 0, then we say that it is a polynomial function. It is a polynomial function whose degree is n. So simply a polynomial is nothing but is the function from R to R defined by the given polynomial, that is defined by, suppose if we have a polynomial 1 plus 2x plus 5x square plus 6x cube, it is a polynomial. Its degree is 3, so it is nothing but it is the function from R to R. Now, like if we consider f of x equals to 5x plus 8, 5x plus 5x plus 5 plus 2x plus 8 root x square. Now clearly this too is a polynomial function, because here the powers or the coefficients or the indices of variable or these integers are simply, we will say that the natural numbers, while as the coefficient here root 8 is simply a real number. Now if we consider the function of the form of h of x, here h of x equals to 1 plus 2 into x raised to power 2 by 3. Here 2 by 3 is not an integer or is not this natural number, so it is not a polynomial, because the index of this x this variable, it is not a natural number. So this means that this is simply a function, but this is not a polynomial function. Here polynomial functions means those where we have this natural degree or the integral value of a number. Now how to draw the graph of this polynomial? Usually we will consider this particular case, and if we consider a polynomial f of x equals to 1 plus x square, this is the polynomial, this is the quadratic polynomial. Quadratic polynomial means the polynomial whose degree is 2. So this means that when we consider it as a function, it is a function from R to R. Clearly its domain is set R, because when we consider x, sum, difference, multiplication of real numbers is always real number. That is why the domain of the polynomial function or the polynomials are defined over entire set R. Now in order to draw this graph, we will draw two axes, x-axis and y-axis. X-axis represents the domain elements, y-axis represents the codomain or the range elements. Here f of x equals to y. Now we will locate few points. When x is 0 in this, y is 1, because 1 plus 1 square, that is 0 square, it is simply 1. Similarly 1 square plus 1 plus, when x is 1, y is 2, because f of 1 equals to 1 plus 1 square, that is 2. Similarly for minus 1 we have 2. By substituting the x equals to minus 1 in f of x equals to 2, we will get f of 2 equals to 5, f of minus 2, that is 5. Now locate all such points. When x is 0, y is 1, it is this point. When x is 1, y is 2, it is this point. When x is minus 1, y is 2, it is this point. Similarly for 2 we have 5, it is this point, and for this we have this point. So this means that we have to, in general, we will join these points. When we join these such points, we will get the graph of this. So this is the parabola, or simply the graph of this polynomial function is like this. It's a u-shaped graph. Similarly, it is home assignment for you. You have to draw the graph of 1 plus x square. You should simply consider or tabulate few points in the domain set, like x equals to 0, 1, minus 1, 2 and minus 2. Find the range elements or find the value of the function at these points. When we find, locate the points on this graph and join such points, you will get the graph of this very 1 plus x square. Now another function is the rational function. Rational simply means the form, when we have the form of the, when the given number or the given expression is of the form of p by q. Here let, what is the rational function? Let f of x and g of x be two polynomial functions, You know the polynomial, what is the polynomial function? That is, f is the function from R to R, g is the polynomial from R to R. Domain of f as well as the domain of g is equals, or because polynomials are defined at each and every point, then if we define a function q of x equals to f of x upon g of x, then this very function is called as the polynomial function. This is a rational function. You know that the rational numbers are of the form of p by q, where q is not equals to 0. Similarly here we have to consider g of x only at those points where g of x is not equals to 0. So this means that this function q of x is defined only when the denominator is not equals to 0. So how to make this non-zero? This is simply by removing those points where denominator is 0. That is the domain of this very function. Domain means where the function is defined, or where we can define the function. So the domain of this very function is simply those points, or those points where this denominator function, that is g of x, is not equals to 0. That is, those points where g of x is not equals to 0 is simply the domain points. So this is the rational function. Inshallah, in tomorrow's video lecture we will discuss few more such functions. So thank you.